am Moiz Ehteshamuddin, Assistant Professor of Mathematics at MVSR Engineering College, Hyderabad. In the previous session, I have given the outline of Mathematics-III-Unit-V. Now we will be dealing all the topics one by one. And this particular syllabus slide we'll see first. You have this syllabus for M3, and we are now dealing with Unit 5. This Unit 5, the first three topics are corresponding to t-test. This t-test is used in these three particular situations, which are nothing but discussed here for testing of single mean, difference of means, and correlation coefficients. The remaining topics are for different other tests. We'll see in the next sessions. Now this is the graph of t distribution for different values of n value 7 or this n value 3, n value 7. There will be different graphs, and these are similar to normal curves. The difference is that the tails will have more area in the case of t distribution curves. So these are some of the curves I have drawn for different parameters, which are nothing but degrees of freedom. T-test depends upon that t distribution. This to be memorized, that are the steps involved in applying any test of significance. When a problem is given, you have to identify which test to be applied, and you have to write the null and alternative hypothesis. You have to calculate the value of the test statistic. For the example, we are talking about t-test, so we will calculate some t value. For f-test, we will calculate f value. So in the case of t-test, in three different cases, we will be having three different formulas for calculating the t value. Once the t value is calculated, we will locate the critical value or the tabular value from the corresponding table. For t-test, we will look at the t tables. For f-test, f tables. Chi-square test, chi-square tables, like that. So depending upon the value of the t calculated and the value of the t available from the table, we will accept or reject the hypothesis accordingly. So this is the main fundamental point to be remembered. You need not look at this graph every time, but this concept should be there in your mind that this particular point is the critical value. I have shown here, you can see this is the critical value of t, and this blue dot may be here or may be here. That is the calculated, this blue dot I am indicating as the calculated value of t. If the calculated value comes greater than the critical value, we will reject the null hypothesis. If the calculated value is less than the critical value, it's very obvious. Here is t value 0, the t is increasing in this direction. So if t is 1 here, for example, then t is 2 here and t is 3 here. So if the calculated t value is less than the critical value, then we accept the null hypothesis. If it is greater than the critical value, it is rejecting the null hypothesis. This particular point is called as this particular point I am mentioning here as the critical value. And this particular shaded region after this critical point will be the region of rejection. So once the t value falls in this region, we will reject the null hypothesis. If we reject the null hypothesis, we accept the alternative hypothesis. Reject the null hypothesis is then going for the alternative hypothesis. In every particular problem, there will be some testing given at some level of significance. If the level of significance is 5%, the meaning is that the area of this shaded region, brown colored, is nothing but 0.05. If it is 10%, the meaning is that it is 0.10. You are all aware that the complete area below this curve, above this axis, horizontal axis, will be equal to 1 unit. And only 5% of the area is covered in this particular shaded region. And it is one example of a t distribution for some n value, some degrees of freedom. And when the test changes, this graph changes, but the concept of rejection or acceptance of null hypothesis is almost the same. Only the change will be in the graph. That we'll discuss in the next test. Now let's solve some numerical problems. To solve that problems, first you need to have the t values. In the case of checking the significance of the difference between mean of small sample and mean of the population, this is the t value we have to calculate. X bar is mean of the sample, mu is mean of the population, s is standard deviation of the sample, n is the number of items in the sample. And this particular t is a random variable satisfying t distribution with n minus 1 degrees of freedom. This is to be used when we look at the tables. And this is the second case where we use t-test when we are checking the significance between the difference of the means of two samples. So this is the t to be remembered. As you are all clear, x1 and x2 bar are the means of two samples. S1 is the standard deviation of first sample, S2 is the standard deviation of second sample, N1 and N2 are the number of items in the first sample and second sample respectively. And this particular t is a random variable satisfying t distribution with N1 plus N2 minus 2 degrees of freedom. When we look at the tables, we have to be clear about this particular degrees of freedom. And t-test is also applied in the third case where we check the significance of the correlation coefficient between n pairs of values, and the t you have to remember as r by square root of 1 minus r square into square root of n minus 2, where n is the number of pairs. Now we will look at some problems. Now you look at this problem. The heights of 8 males participating in an athletic championship are found to be these heights. Okay, these are the 8 numbers for 8 males. These are representing the heights. Can we conclude that the average height is greater than 165? Here it is not said, but it is understood that we are talking about the average height of the population, that is 165. And here we have to test whether the average height is greater than 165 for the population. So it is talking about mean of a sample and mean of the population. So we are taking the first case of t-test. Here we are defining the null hypothesis, that is the neutral hypothesis, assuming that it is neither greater nor less, it is just equal to 165. It is the neutral hypothesis, also called as null hypothesis. If this is rejected, there are several possible cases, that is mu is less than 165, mu is greater than 165, or mu not equal to 165. That 3 possible alternative hypotheses are possible. But the point is, there is a claim in the question that can we conclude that the average height is greater than 165. So this is taken as the alternative hypothesis, that is H1, H not H1, H not for null and H1 for alternative. So this mu, which is the mean of the population, we will take it as greater than 165 as per the given claim. We need to use right tail test because we are talking only about mu lying on right side of 165. Here n is equal to 8 and degrees of freedom are n minus 1, that is 8 minus 1 7, and the given level of significance is 5%. From the table of t distribution we have t7 of 0.05 is equal to 1.895. In the first session I said how to look at these t tables, and also in this particular PDF it is there at the end, you can see the tables. Now to save time I am not going for the table, you can visit to see that particular session. Now this is the tabular value. Now x bar is 1 by 8 of this 8 is number of items in the sample. I am adding all the 8 elements, I am getting 168.25, and I am calculating here the shortcut for standard deviation. S square is equal to 1 by n into sigma x square minus x bar square, and I got that is 18.9375. so this is the value for s square, so s turns out to be 4.3517. Now we'll come to the test statistic. This is what is to be remembered always. Whenever we take up the t-test, we are dealing with one of the case. In each and every case there will be some t value, that is there will be some formula for t which is connected to that case. So t is x bar minus mu by s by root of n minus 1. It is just a substitution of the x bar value, which is the mean of the sample x bar, and mu is the mean of the population 165, s is 4.3517 just now calculated s value, and this root of n minus 1, that is 8 minus 1 root 7. This on simplification is 1.976. This is the calculated value for, now I'll show here, this particular t is finally coming as 1.976. This is the calculated t value. And in the previous slide we have seen that this is the tabular value. We are looking at t tables with 7 degrees of freedom at 5% level of significance. For single tail, that is right tail, if the table is available for 10%, you have to see, if the table is available with 2 tails, you have to see at 10% level of significance. Okay, now this calculated t value is 1.976, that is this one, 1.976. It is more than 1.895. so if you look at this particular graph, this critical value is 1.976 something, and this calculated value is here. .976 is the calculated value and critical value is 1.895. so we will be going as per that rule, that we reject the null hypothesis and accept the alternative hypothesis. So we say that average height is really greater than 165. Now let us see the second example. The following two independent random samples of sizes 10 and 8 are given as follows. So there are two samples given. Is the difference between the sample means significant? When two samples are given, it is clear that we are not in the first case. Now let us look at the second case. Earlier I discussed this slide, you can look at this one here. Test of significance for difference between the means of two small samples. So this is the t value we need to calculate. So here two samples are given. The mean of this sample and the mean of this sample will be of course allowed to be different, but the difference, whether it is significant or not, that is what we are checking here. Is the difference between sample mean significant at 5% level of significance? Here n1 is 10, n2 is 8, that is number of items of first sample, number of items of the second sample. We need to calculate the means and variances of the given samples. So sample 1, these are the x1 values for the first sample, and here because the values are bigger values, I am taking the deviation from that 165, that is approximately the assumed mean is 165 I am taking, and I am removing that, I am calculating the deviations. So I am calculating standard deviation by deviation method. I am removing, you can assume any number other than that 165, of course it is allowed. So by taking this u, I am calculating this u square. Similarly for second sample I am calculating these values. Now x1 bar is 165, which is assumed mean, plus the mean of these new u values. So 165 plus 1 by 10 times of 13, that is this particular u will have some summation here, that is sigma u, that sigma u is 13. So that u bar is nothing but sigma u by 10, that is nothing but 13 by 10. So this 13 by 10 is the figure to be added to 165 to get the actual mean of this x1 series. So it is going to become 166.3, and s1 square is 1 by, this is the shortcut formula for standard deviation which we already used in the previous problem, but we have used deviation, and this deviation deviation will not change any value for the standard deviation. Finally it is going to be 8.41. so we are ready with x2. Similarly for the second sample, and s2 is ready. And then here we assume that the null hypothesis x1 bar and x2 bar are equal, means there is no difference between the sample means. Means the difference has come only as a random case, it is not significant. That is what we are assuming. But alternative hypothesis is that they are differing significantly. Means we mean to say that these two samples are having two different means, their difference is significant, it is important. Okay, and the degrees of freedom are n1 plus n2 minus 2, that is 16, and the given level of significance is 5%. So look at the t tables, you will be getting this particular t value as 2.12, and you know in the next slide that t which we have to calculate is x1 bar minus x2 bar by square root of this figure, this particular expression, this into this one. So this particular expression I have separately calculated earlier, this n1 s1 square plus n2 s2 square by all these things. So finally it has come as 11.0620065. so this t I have calculated, and the t has come as 1.144. This is the value of t which is calculated, and in the previous slide we have written just now here that 2.12. This is the critical value, and 1.144. okay, I'll highlight it. Now 2.12 is 1, that is the tabular value, that is the critical value. 1.144 is calculated value. Calculated value is less than tabular value. Therefore we accept the null hypothesis that there is no significant difference between means of two samples given. So whatever difference is there in the two samples, it is just allowed at a 5% level of significance. The difference is not much, that is the difference is not significant at 5% level of significance. Now this third example corresponds to the third case, that is we are checking the significance of correlation coefficient. Again, as I mentioned earlier, we need to use some t value. The t value is here in this particular case. It is given that there are 27 pairs of observations from a normal population, gave a correlation coefficient is this much. So can we accept that this correlation coefficient is significant from 27 pairs coming from a normal population? Is this significant of correlation in the population? So first of all, the null hypothesis, we assume that the rank correlation coefficient rho is 0, means there is no correlation and the coefficient of correlation is not significant. But let us decide it as per the t value. So t value is this one. So t is coming as 3.75. By substituting the values of r, all these things, it has come as 3.75. So the tabular value is to be taken for n minus 2 degrees of freedom. Earlier I specified that it is satisfying t distribution with n minus 2 degrees of freedom. There are 27 pairs, so 27 minus 2 is 25 degrees of freedom. At 5% level of significance, it is 2.06. Since the calculated value of t is greater than, because just now we have seen it is 3.75 calculated value. I think I missed some of steps here. I did not mention how that has come, but it is just the simplification of this t value. So at 5% level of significance, the critical value is 2.06 and 3.75 is the calculated value. Calculated value is greater than the tabulated value. We reject the null hypothesis and accept the alternative hypothesis that there is a correlation in the population, and the correlation coefficient is playing a role, that is it is significant. These are the t table values, and for interested students, those who want to understand how that particular graph of t distribution has come, they can visit this particular function by giving different values of t, and n is the degrees of freedom. For example, if I write n value as 5, then this 5 and here 5 is substituted everywhere in the place of new, that 5 is substituted, then this is a function of only the variable t, and you will get a graph, and it is very clear that it is using even power of t, so there will be no negative value for f of t, and hence on the left and the right the value of the function is above the t-axis. This is the short description of the t distribution, and numerical problems related to f-test and chi-square test will be discussed in the next parts. I'll discuss that f-test in one session and chi-square test in one more session. Thank you.